Wireless LAN Professionals Podcast, episode 151.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Hello again, Keith Parsons here with Wireless LAN Professionals Podcast, and I'm with Curtis Larsen today. And we both happen to be in Utah at the same time. How are you doing, Curtis?
Doing great, Keith. How are you?
Great. Nice and hot here, but that's what happens in the summer in Utah. I thought we could talk about something you had mentioned you've done in your network there, and it's a little unique. I've recommended it to some other of my customers, and they seem to like it. It is running a 5 gigahertz only on SSID. So tell us about your experience with it.
Well, yeah. So for a long time, we've had 3 SSIDs here on campus, or of course at the University of Utah and the University of Utah Hospitals and Clinics. And so we have a primary .1x SSID. We have EduRoam. We have a guest network. And actually, we've recently added a 4th one with the Identity PSK feature. But basically, what we wanted to do is we wanted to take our primary SSID that's been dual band for since its inception, really, probably 10 or 12 years ago, and we call it Uconnect, and we wanted to make it 5 gigahertz only, and so we piloted that here in our IT building for probably 6 months, and we sent communication out and made the change, and we didn't get a single ticket. We got nothing but good feedback from our users.
So when you say you didn't get a single ticket, so no one actually made an official help desk. Did anyone talk about it though?
I definitely ran into people in the hallways that said, "Hey, Skype calls are working awesome now," and because people were aware that the change was coming and that we were making it, that we're trying to improve things here in the IT building. You're familiar with our IT building, Keith, and there are other improvements that we've made over time, but that was one that really kind of stuck out as hey, things have improved significantly since we moved to 5 gigahertz.
Did you have any, I'm thinking more layer 8 kind of political pushback from management going, oh no, we're going to turn off 2.4?
There were definitely questions of, how will this impact people? And if we have people with legacy devices, with 2.4 only devices, what will the fallback be? And so for us, our primary SSID and EduRoam are somewhat redundant, actually. And so in our communication that we sent out, we said, hey, you know what? EduRoam is still there. It's still dual band. If your device doesn't work, feel free to connect it to EduRoam. Or, hey, you might consider upgrading your device. And, I think we even sent out a link from Amazon with, USB Wi-Fi adapters that were 802.11 AC and were under $20 or something. So, we definitely got the questions. We tried to prepare by, having a fallback SSID and, the possibility of connecting to our guest network or getting a USB Wi-Fi adapter as well. But when we made the change, we watched the statistics, and the numbers of people connecting to our primary SSID stayed high. And we did not receive any ticket saying, hey, my device was working yesterday and it's not working today. We assumed that some of those were because they made the change and they went to EduRoam instead. But the statistics showed that was small. Those numbers were small. That was when we did it here in our IT building. So
what, in your IT building, what was the ratio before of EduRoam to your Uconnect? Were many people using EduRoam as it was?
EduRoam has always been a small adoption rate for us. So it's, I would say it's probably less than 5% of our users connect to EduRoam. And after the test, it might have gone up just a hair, but, maybe 6% or something like that. So relatively minor.
So after a trial in your building, how expansive did you make the change next?
Yeah, so the next thing that we decided to do is look at our student housing areas. primarily because we know that they have really they have good 5 gigahertz density. So we have site survey results, of course, of all those buildings, and really about a year and a half, well, about 2 years ago, we ended up putting, in addition to the APs that were down the hallway in the beginning, we used the Cisco 1810 series, the wall mount APs in the rooms, and so we have about every other room has a Cisco wall mount AP, and
Are those 5 gig only? Do they have the 2.4s off?
No, they are dual band, but yes, we have turned some of the 2.4 off. But yeah, so but we knew that hey, if we've got the density anywhere besides our relatively new IT building, we have it in housing. So we have about 20 student housing buildings, and we said, okay, let's communicate out the change. Let them know that we've had success with the pilot here in our IT building, and we made the change there. And that was just it's been about, I think, a month ago or so.
So any tickets show up from that one?
So not a single ticket. No, I mean, we did plan this change to be after finals, and so obviously probably some of the students moving out quick and things like that. But we still have some users in there, and they have we have people that come in during the summer for different events and things like that. We still have a good number of users over there, and we've had them over there for enough time that, hey, if there were things that were working yesterday but are broken today, we really should have gotten something.
And EduRoam is still available there?
EduRoam's still available there. It's dual band, 2.4 or 5, and the guest network is dual band as well. And then we have an SSID that we call Ulink that we're piloting over there for pre-shared key, and that's going to turn into our identity PSK SSID soon. So that's where people put their IoT things, smartphones, Xboxes, Roku players, those gadgets, and things like that. And so those networks right now they're still dual band, but we just said, hey, let's take that big one, Uconnect, our primary SSID, that one that 90% of our users are usually connected to, and let's start making that where we know we have the design that can support that. Let's start making those 5 gigahertz only.
So between the two tests, the one in your IT building and this new housing, any statistics on throughput, average MCS, retry rates, or something since you switched up to the 5 gig only?
We looked at a lot of statistics before and after, as far as like percentage of people connecting on 2.4 and 5 and things like that. And basically it stayed. I mean, we got more people connecting to 5 gigahertz on Uconnect. Everybody on Uconnect is 5 gigahertz, but the numbers didn't change a ton, because there's obviously some benefit, but yeah, we didn't get as detailed as to go in and say, hey, let's look at MCS rates and things like that. We have some, or retry rates, or speed test results or anything like that. But yeah, the feedback that we've got so far has been really positive. One thing that stands out is, you can take a look at our management dashboard in Cisco Prime, and just look at channel utilization on 2.4 versus 5. And even though we have all of our users on our primary SSID in those buildings on 5 gigahertz, the utilization is lower. It's lower on 5 gigahertz than it is on 2.4, which tells you we probably have probably too much 2.4 in a lot of places.
And which means, that's the whole purpose of moving people to 5 gig is for each device that's 5 gig capable, if they're on 2.4, they're having a bad day and they're causing someone else to have a bad day. So if you can get them up to 5 gig, they're having a better day, and the people who can't go anywhere else get better as well. It's kind of a win-win there.
Yeah, absolutely. And that was our goal, to see if we can take some of those dual band clients that for whatever reason, occasionally are choosing 2.4 when 5 is really a better choice probably. And so we feel like we have taken some baby steps towards, a 5 gigahertz only SSID organization wide.
Have you ever thought about doing kind of the reverse, perhaps on that IoT SSID to make it 2.4 only?
Absolutely. Yep, I've proposed that already. We've been in discussion with architecture and my management on that. So, yep, we're right along those lines. We're considering 5 gigahertz only on our primary SSID, and then perhaps a 2.4 only IoT SSID and a 5 only. So it's split, 2.4 only and a 5 only. But yeah, we're looking at those scenarios. Yep.
But with different SSIDs on each.
Right. Yeah. So
if you have an Xbox that can do 5 gig, you go to 5 gig.
Exactly. I mean, the same logic that we've used on our primary SSID to say, hey, this is a good thing. We really want to apply that to for example, our IoT SSID, and except for give them a fallback, because obviously we have a grundle of IoT devices, especially in the hospitals and clinics and housing areas, and especially in the hospitals and clinics that don't do 5 gigahertz, right? So we want them to have a IoT SSID that's 2.4 and an IoT SSID that's 5. But it's going to take us a little bit more time to work out some wrinkles in that.
So what's the next step on primary SSID 5 gig only? You have way more than 20 buildings. Yeah,
so we're close to 300 buildings here, and so what we're doing now, we did a lot of work with you, Keith, and took some inspiration from Devin Aiken, and also worked closely with Mike Albano on developing and updating our Wi-Fi design best practices. And so we've, maybe the last 6 months to a year, we've probably updated the design in maybe 10 different buildings. And as we update that design to our standards, to the standards that we think match the Cisco Apple design guide, where we have, dual 5 gigahertz, 2 good 5 gigahertz APs available. And after we've updated those designs, we're also making those 5 gigahertz as well. So really, we're probably up to about 30 buildings right now that have our primary SSID with 5 gigahertz on. And then it's going to be through attrition as we get a chance to update those designs, because we have a lot of updating to do. A lot of our designs are outdated, and it's a catch-up game. So as we update them, we go to 5 gigahertz only.
You're also involved in EduRoam. EduRoam to date has had to be in 2, 4, and 5 simultaneously, exact same SSID. Have you heard anything about switching that up to give options in the future?
I've read occasionally a thing here or there on, maybe the EDUCAUSE wireless list or, Twitter or different things about the possibility of EduRoam being 5 gigahertz only. So for us, every institution uses EduRoam differently, or maybe, or looks at it a little bit different. Someday maybe it's possible that EduRoam could become our primary SSID, but today we don't get that type of adoption. So it wouldn't make sense.
Some edus already have made that jump. I've actually seen EduRoam in hospitals that aren't tied to schools and airports and all sorts of crazy places.
Yeah. I love the concept. I love the concept of federated authentication. I love the concept of seamless connectivity, without reconfiguring. I don't love the concept of an extra SSID that doesn't match the branding of my institution. And sometimes I think that can lead to...
Well, there is a big U in EduRoam, so you just need to make it red or something.
Yeah, there you go. Maybe we'll have to suggest something like that. But so today for us, the EduRoam utilization is a lot lower, and we do have a kind of a groundswell of, as of some of these the K through 12's adoption of EduRoam growing, and we think, hey, maybe as that adoption grows, then it will grow when they come to campus. When they come to our campus in our organization, they'll use EduRoam more. But so far, it just hasn't panned out. Most of our documentation still points people to what we call Uconnect. And so right now, EduRoam is just a good fallback for us with 2.4 enabled. But yeah, maybe someday down the road. I'm not a fan of having SSIDs that are redundant. Obviously the beacon overhead and extra airtime there with the management frames. And so I would love to see those be consolidated. And I don't really care whether it's EduRoam or Uconnect, but I'd really like to have one. But as it stands right now, we've had EduRoam for several years, and it works for a good 2.4 fallback for us for now. And it allows us to push forward getting people to 5 gigahertz only on our primary SSID.
Well, since we're talking about SSIDs, what do you think about the Wi-Fi Alliance's new guest encrypted system that they've just announced? Have you looked into that at all?
I think you're referring to the opportunistic wireless encryption. Is that the name for it?
That's the technology, but they've wrapped it in a different thing where if you want to offer this, you have to have a fixed SSID, and then all client manufacturers will load that same fixed SSID into their systems. So it's kind of a chicken and egg thing. You have to have it, but then the clients have to have it. And if both have it, then you have the ability to have a non-eavesdroppable eavesdrop. People just can't eavesdrop in on your traffic like they can with the PSK.
Yeah, so I'm interested to learn more about that. I've heard just a little bit here and there and read just a little bit here and there. Right now, the solution that seems more baked for us is the identity PSK feature, or similar to like what Ruckus and Arrow have had with the dynamic pre-shared key or the personal pre-shared key. So
but you're a different company, so you have to take the same thing and call it a different name.
Yeah.
Your marketing requires it.
Exactly. But we've had we've done some pilot testing here with the identity pre-shared key, where we can allow our students to create their own pre-shared keys on the same SSID. And if they have 5 devices, they can create one pre-shared key and use it on all 5 devices. And
what's the limits on that on the high end, since you have to kind of have those loaded up someplace where an AP can look it up?
That's done on the Radius or the backend identity services engine, or it could be done on Radius. That's a good question that we need to look at. But I mean, gosh, I know that we do MAC authentication on our against our guest network today with backend free Radius servers, and we do. Our guest network is only 10% of our users, but when we get 40,000 clients at peak, 4,000 of them are guest connections, and they're doing MAC auth, and we don't have any trouble with that. We haven't had the trouble with that in the past. I don't know that out of the gate we're going to get more than 4,000 devices at peak on this IPSK system. But yeah, it's definitely, there's a database component there, and so
Well, and what I was kind of alluding to was Cisco chose to do it a lookup method. And you have to have the ISE behind it. Ruckus and Arrowhive have a different technology where they actually have to share those out inside APs, and thus you're going to hit a limit a little sooner.
Oh yeah, I didn't recognize that difference, but that's definitely intriguing. I know that IPSK is a feature that is now working on the Cisco 8.5 code and above, and so we've been doing that. Our understanding is that it could be done even with an external Radius server that's not Cisco ICE. But in this case, we're choosing to try it out with ICE, and we have a redundant configuration where we've got one ICE server in one data center, another ICE server in another data center, and load balancing. And I think we'll probably be okay. But yeah, I think I'll probably look up and see, hey, is there a limit on this database size? Or
well, if you're doing MAC auth already, you're already doing something very similar load wise. Well, Curtis, thanks for talking to us today about your 5 gig only primary SSID, and actually really good to hear that not one ticket on either of your 2 trials. So that's got to help kind of give you a warm and fuzzy feeling about rolling it out elsewhere.
Yeah, it does. Absolutely. We were ecstatic to see those kind of results, and it just gives us a lot more encouragement to keep kind of implementing those best practices one by one and improving our wireless network every day.
Great. Well, thanks for your time.
Hey, thanks a lot, Keith.
Tools review.
Hello, Keith Parsons here again. I'm going to put together a series of little short podcast interviews, basically with myself, talking about a project that was my pet project earlier this year that we completed and finished in time for the WPC in Phoenix in February. And it's a little notebook. Actually, if you're a bigger guy like me, it actually fits in my back pocket when I'm wearing jeans. It's a notebook kind of designed with a bunch of special features in it. And then we'll talk about some of the features, each in an individual little tiny interview that we're going to stick inside the rest of the podcast episodes. So for this first one, we'll just talk about the size, shape, and the impetus behind building this. Years ago, when I first started I was in commercial real estate for a long time. Having a notebook with you, something to write with and something to write on, was critical. No matter where you are, you have reasons to take notes. So I've been kind of a collector of all sorts of different types of notebooks over the years. Went into Moleskine little books for a long time. It was my go-to, and having a pen that I could use and was with me all the time was important. So in the wireless world, many years ago, I saw a Xeris, the company Xeris made a little notebook. It just happened to have all the right features. I used it for a long time. I've seen a lot of people use them. It had the right size, and it was just useful. So I thought, for wireless LAN professionals, what size do we need? What do we need it to act like? So we came up with a notebook with a metal spiral bound. It happens to be 16 by 9 is the aspect ratio. One, so when you're working on screens, it's the right aspect ratio for doodling up what an interface would look like on a screen. It has the front and back covers are a certain size and hopefully the right thickness. Now that I play with it, I think next cycle around we might make them a little thicker. And then inside, we wanted to add pieces that could be useful as resources. So we'll be talking about each of those individually, but the text itself in the middle, the blank paper, is also designed specifically for doing the kind of jobs we do. I've used graph paper for a long time because it's easy to line things up, and when you're scribbling, you can make straight lines and space things the appropriate spacing away. But graph paper looks a little high schoolish. So in this case, we ended up, instead of with graph paper, we used little teeny, kind of a light gray dot, and the dots are in a 5 millimeter grid. So you can use these to draw anything you want and just kind of think of them as graph paper. We didn't make it too full. We specifically made it this size so that when you lay it flat, it stays flat. And you can flip the front around and you can take notes either vertically or horizontally. So that's kind of the start of our little podcast project talking about the Wireless LAN Professionals notebook. We'll have some other little blurbs that are going to drop into future episodes talking about each of the different pieces and why they're there. Thanks for listening. I hope if you got one at WPC, you use it. If you have other feedback and you'd like to have other things in your next version, of course, we'll be coming up with newer and better versions along the way. We'd love to have your feedback. Thank you very much.
10 Talks.
For the next 10 minutes, I'd like you guys all to think about antenna patterns and the shapes of these patterns and how these patterns are imported into our predictive designs. At the end of this talk, I'm going to show you guys a different way that we can model these patterns that might reduce some of the errors that we find in our predictive designs. So just to level set, I just want to talk about my definition of what I'm considering a predictive design. The designs where we're simulating the shape and the pattern that comes out of the antenna, its RF signal strength, and its propagation pattern. You have the option, if you wanted to collect measurements on site, do some spot checks to get some attenuation for the walls, and import that into predictive design. And this will help you reduce the error that you have in your design. Taking this approach, you don't need to spend as much time on site, but your design is heavily dependent on the inputs into your design. So the accuracy that you incorporate for your attenuation and the accuracy of the propagation pattern from your antenna contributes to the amount of error that you have in your design. And so the risk with predictive designs, if you don't account for accurate inputs, you may end up spending a lot of money redesigning your network after it's been deployed. So you've all worked as wireless professionals, and you spent a lot of hours of your day trying to minimize co-channel interference and eliminate from your design. So when you come home and you sit back and you relax, you think about unanswered questions of the universe, like, is the glass half full or is the glass half empty? Now, I know some of you have already heard this, and you've probably heard that the pessimist would see the glass as half empty and the optimist would see the glass as half full. But to an analytical mind, as a technical approach with a keen business sense, this glass might appear twice as large as it needs to be. There's a lot of sunk cost in glass that's not holding any water. Some people describe the glass as full. It's half full of water and it's half full of air, taking it right up to the brim. So it raises an important question. Sorry, what are we referencing? What are we trying to compare? Are we trying to bring the water right up to the top of the glass? If this is the case, you might hear people talk about the ability to form or to displace the water and pretend that the water gets up to the brim. So you might hear people talk about the benefits of ice. Now, other people might talk about enhancing the water. If they could somehow provide you half a glass of water that could quench thirst 10 times faster, they might be able to gain some incredible market penetration. But enough about philosophy. Let's move into space, the final frontier. So some people see this as the sun, a big ball of light in the sky. To me, this is a good example of an isotropic radiator. It's radiating energy equally in all directions. So if you were to look at the top down at the sun, you'd see energy in 360 degrees uniformly radiated. Now, this is theoretical. In reality, we see something that looks more like an amoeba. So when a biologist looks at this picture, they see all different parts of an amoeba. When I see this, looking into predictive design, I see a coverage map. So instead of a cell membrane, I see my cell edge, where the nucleus is. That might be the only area with enough SNR to properly demodulate 256 QAM. I see some contractile vacuoles. These are areas of moving bodies of water in my design, some pillars that are made of concrete or metal that attenuate my signal that I have to account for. I also have food vacuoles. Now, to me, I see this as my high-capacity users, people that are consuming a lot of airtime and bandwidth. Right, so I have to be careful of these users. And in this particular picture, I see a food module that's outside my coverage area. So this is a high capacity, high bandwidth user in a dead spot, which probably means I'll get a lot of phone calls from that user. And so what if we wanted to model our own antenna patterns and try and manipulate the shapes and maybe visualize how that pattern looked as we reviewed it across the distance? Fortunately for us, about a year ago, Wi-Fi Nigel made a blog post on his website where he did just that. He created an Excel spreadsheet where he could load the data around the 360 degrees of your circle, import that into the spreadsheet, and in one of his tabs, he'd generate the polar plot for you. And on another tab, he'd translate that into distance. So on the, you guys' left-hand side, you see the polar chart, and on the right-hand side over here, we see that translated into distance. Now, it's a fantastic spreadsheet, and if you go to his blog site, at the bottom of his blog post, he has a link where he actually shared the spreadsheet with the community, so you can download that and build your own maps. But the challenge here is getting precise data. If you don't provide enough points, you end up with some blocky graphs. And so if there's only a place we go where we could easily get some granular data for these channels or for these polar plots that we wanted to graph. Fortunately for us, and fortunately for everyone at this conference, you now have software where we could do just that. So once you get that software installed, if you would navigate to the program directory and then to conf antennas, you'd find a list of about 1,000 files in this directory. And these are XML files that represent the antenna patterns for all the patterns within that database for that site survey package. With them being in XML format, they're text files that you can open and read. They are separated by H-planes and E-plane. We're interested in the H-plane data, which will give us our omnidirectionality. And these files have to be broken down either by degree, by 3 degrees, or by 5-degree increments, which gives us some pretty granular results. So if we combine the data from these structures with the spreadsheet that Nigel provided us, we might end up with something like this. So the graph that we see on the right is where we have the glass full of water. The signal's propagating all the way to the edge of our polar plot. And what I'm representing here is an antenna that's advertised as a 4 dB gain antenna and omnidirectional. So here, with the glass half full, we're filling the entire circle with energy. But the actual gain, if we model this antenna, would look like what you see on the left. So only for a very small amount of time is the signal actually reaching the 4 dB gain point. In fact, there's a couple spots where it drops to -2. So we have a delta of 6 dB of gain across our 360 degrees circle. And if we look at the distance, we see our glass full, we're propagating about 86 meters. If we look at what actually happens, for a brief moment in time, again, we're at 86 meters, but we drop down to as low as 43 meters, which kind of lines up with our 6 dB delta. If we have the distance, it means we've lost 6 dB. If we doubled the distance, we've gained 6 dB. So the math works out. But we're missing a lot of space. There's a lot of error in our diagrams. And we have an error of 43 meters, right? We're off by quite a bit. What if there was a way that we could reduce some of this error? What if we took the average of all the plots around that circle and graph that? It turns out for this particular antenna, if you were to average all the points around your graph, you'd end up with an average gain of 1.21. So we can see this is what the circle would look like if it was uniformly radiated across our polar plot. And we just compare that to what you saw before of the actual gain of the antenna. And if we look at this over distance, now this time in distance, we're radiating to about 65 meters, right? So we're within 20 meters now of our fringe cell, which used to be 83 versus 43. Now we have a distance of 65 meters radiated in all directions. So we reduced our margin of error in our design. And if someone challenged you and asked you, is 3 dB really a lot? Is 6 dB a lot? I recently heard a line, well, I guess it was a while ago, that Matthew Gast gave some advice. If you want to convince someone 3 dB is a lot, ask your boss for a 3 dB raise, right? See what the answer is there. And so take this a little bit further. What I've done with this chart is I've captured some antennas, and I tried to keep this as vendor neutral as possible, so I haven't identified the models of access points. But the first block of 4 have come from the same vendor, just different models within the family. They're all advertised as 4 dB gain antennas. But when you average all the points, you end up with that 1.21. And here I just graphed the minimum maximum distance and the deltas. So just to qualify the distance where that came from, within Nigel's spreadsheet, I was assuming it was a 2.4 gigahertz signal. I assumed my signal drop-off was negative 65, and my transmit power was 10 dBm. So depending on those variables, your distance, of course, changes. What I also think is interesting, on this last access point, it's advertised as a 3.5 dB gain antenna. But what we're really seeing is a normalized gain of 2.01, or 2.09. But if you look at the distance, using those same inputs and variables, we're seeing a delta of 106 meters, which is a lot of error in our designs. So it might be better, we might have less error if we were to use the normalized gain for that particular antenna and keep it uniform within our graphs. So just to wrap things up, be aware that when we talk about omnidirectional antennas, they are definitely not uniform in all directions. They do, in fact, look like amoebas. If you want to account for that to design, this is one approach that you might want to take, where you average the gain around your polar plot. It also gives you some insight into the characteristics of the antenna. It gives you some idea of the quality of the antenna. The closer they get to having uniformity around their polar plot, the better off the antenna design and the better it'll perform for your network. And this is also, because of the variable, one of the many reasons that you want to validate your design. So always, always, always validate your design once it goes in. And if you have any questions or comments, once again, I'm Troy Martin, and you can hit me on Twitter at TroyMart.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter at Wireless LAN Pros for all the latest news and updates, and also connect directly with Keith on Twitter at Keith R. Parsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.